All right, so today we're going to look at factoring. Yesterday we used the magic X or diamond. We're going to use that technique today when we factor polynomials. So every time we do a factoring polynomial problem, we are going to create a magic X or a diamond. The other technique from yesterday was GCF. We're going to continue to apply the GCF to problems with factoring also. The GCF is the first thing you want to look at or look for anytime you're factoring a polynomial. So GCF is the first thing you want to look at for any factoring problem. So let's just go through and reiterate. The GCF is the greatest factor that divides two numbers. As we progress in our algebraic state, that definition expands a little bit. And it can be the greatest common factor that divides two numbers, variables, etc. So you want to find the GCF of 9 and 24. So that means the largest number that divides into both. Well, 9 divides by 1, 3, and 9. 24, the largest of those is 9. 24 does not divide by 9. So the next largest is 3. 24 does in fact divide by 3. So the GCF of 9 and 24 is 3. You saw yesterday we expanded from just numbers to numbers and variables. So in example 1, you have 5x squared plus 15x. The GCF here is the numbers and variables that divide into both. So both numbers divide by 5. The first one has an x squared, the second one has an x. So that means both could be divided by x. So 5x squared divided by 5x leaves x. 15x divided by 5x is 15 divided by 5, which is 3. And the x's cancel out completely. So again, that's just our way of reviewing factoring out with a GCF. The next part we're going to look at is applying the magic X to factor these polynomials. Now the first ones you guys might be able to just do on your own because you remember how to factor. But the idea is that you're multiplying the number in front of x squared and the number at the end together, so 1 times 12. The middle number goes on the bottom, so 7. So I'm looking for two numbers that multiply to 12 and add to 7. Good? Perfect. If the number in front is a 1, then we can fill these two numbers in to the binomial parentheses like so. We did 0, 2 the other day. That was on FOIL. Anytime you factor, you can check what you've done. It should FOIL back to the original. So like there's x squared, there's 12. So that's your first and your last. Your outer would give you 4 plus 3, which gives you the 7 you're looking for in the middle. So again, you can always check with like a quick FOIL. The value on x squared is 1 again, so we can just fill these in. So I need two numbers that multiply to 14 15 and add to negative 9. If the bottom number is negative and the top is positive, then both numbers I'm looking for are negative. Good? Perfect. Negative 2 and negative 7. Doesn't matter what order you write them in. I can write x minus 2, x minus 7. That's the same thing as x minus 7, x minus 2. They're the same. First number is still a 1, so these are still kind of easy. Factors of negative 24, but add to 2. Top's negative, bottom positive. That means we have 1 negative and 1 positive. Ryan? Perfect. So 6 and negative 4. All right, the ones on the back begin the trickiness. The ones on the back begin. Because now the number on x squared isn't 1, it is 3. So what you have to do is multiply the first times the last. So 3 times negative 15 is negative 45. I need two numbers that add to 4 and multiply to negative 45. What do you think, Colton? 9. Perfect. Positive 9, negative 5. I have to now, this is an extra step because there's a number 3 in front. These two numbers now are going to replace this number right here. And if you recall, we're going to do something called factor by grouping, which is basically taking out a GCF. That's why we learn the GCF. So we're going to rewrite this, and if we have a negative number, we always write the negative first. So we're going to rewrite it as 3x squared minus 5x plus 9x, because again, we're replacing this 4 with the numbers we found. And then the negative 15. When you have 4 terms, we factor by grouping. So what that means is we're going to group the first 2 and the last 2. And then what I want you to do is find the GCF of each of those parentheses. So what's the GCF of 3x squared and 5x? I can only take out an 1 and an x. That leaves behind 3x minus 5. What can I take out of a 9 and a 15? Right? Good. So we're going to take out a 3. And that leaves behind 3x minus 5. So do you notice that this is the same as that? They have to be the same or you did your math wrong. They have to be the same or you did your math wrong. 3x minus 5 is one factor. The other factor is x plus 3. Remember how I told you can check with FOIL? Your FOIL check is actually this line right here. Factoring using this technique is called FOIL in reverse. 3x times x is 3x squared. 3x times 3 is 9x. Negative 5x, negative 15. So this technique is FOIL in reverse. It will work to factor anything that is factorable. It will work to factor anything that is factorable. I told you, the first one or two are really hard. Once you do it like twice, sometimes 3 times, it's like, okay, I can do this, because you get into a rhythm. So first number times last number. Middle number. 2 numbers that multiply to 45 and add to negative 18. Hint, look at the problem above. Colin? Yep, negative 3 and negative 15. We're going to take those and replace the negative 18. So you get 5x squared minus 3x minus 18x plus 9. You're going to do factor by grouping. Now look at my screen. Where did I put the parentheses on that negative number? Is the negative inside or outside? It's inside. When you do factor by grouping and in the second terms you have a negative, you have to group it on the inside. You have to group it on the inside. 5x squared minus 3x as a GCF of x. Leaves 5x minus 3. This is why that negative needs to be on the inside. If the negative is right there after the parentheses, you are factoring out a negative. So I'm going to take out 18 and 9 divided by 9. I'm taking out, oh, I wrote 18. Guys, I'm so sorry. That should be a 15. So 15 and 9 divided by 3. So I'm taking out a negative 3. That leaves behind negative 15 divided by negative 3 leaves a positive 5. 9 divided by negative 3 leaves a negative 3. If you don't take out the negative, your two sets of parentheses will not match. So you get x minus 3, 5x minus 3. Number in front, number at the end. This is where the technique really starts to come into play, because now you're looking at significantly larger numbers. So 9 times 16 is 144. I need factors of 144 that sum to 24. What two numbers multiply to 144? Yeah, 12, right? So 12 and 12. Replace your middle term. And take out the GCF. I'm going to walk around and look at each of your pages to see how you do. All right. So when you group the first two, you take out a 3x. That leaves you with 3x plus 4. When you group the second two, you take out a 4. That also leaves 3x plus 4. When my two parentheses match, I know I've done it correctly. So I get 3x plus 4, 3x plus 4. Okay, and then this last problem, the magic X works for this. First times the last leaves negative 49. There's no middle, so it's a 0. So the question is, what two numbers multiply to negative 49 and add to 0? Well, the only way two numbers add to 0 is if they are the same number, but one's positive and one's negative. That's called the additive inverse. So what two numbers multiply to 49 that are the same number? 7. So that's negative 7, positive 7. You can do factor by grouping if you want, because you forgot that that front number is a 1. So the factor by grouping works even if you have a 1 out in front. So we get x minus 7 plus 7, x minus 7, or x plus 7, x minus 7. This type of problem also has a special name. It is a difference of squares. A difference of squares will always factor as the positive or negative. A difference of squares is a squared minus b squared. Difference representing the negative. Squares because they're perfect squares. And it always factors as a minus b, a plus b. So if on your homework you see something and it just has two numbers and they're both perfect squares, you can apply the formula. That assignment is due over the weekend. I'm going to be posting answer keys to the assignment you turned in on Wednesday today. And then after I get all of these checked, I'll be posting answer keys to that. Your answer or your assignments need to be uploaded as a PDF. After about the next 1 or 2 assignments on Moodle, I'm just going to make it that it has to be a PDF and it will deny your images. Office Lens and Genius Scan both work wonderfully, or Genius PDF.